All right, so this is part one of a three-part lecture series talking about Newton's laws of motion. So Newton is credited for making his three laws of motion. So this lecture is going over the first law. But to give you some background, so these laws describe, so these laws describe why objects move or don't move. So Newton was very interested in explaining why and I guess understanding why things are either at rest, why things stay moving, why things slow down, and how things get moving, right? So the first law okay, it's also referred to as the law of inertia. And this law has actually two parts. So the first part, okay, says an object at rest will stay at rest. Okay. And an object in motion will stay in motion. So what's important to note here is that if it's at rest, it will stay at rest, and if it's in motion, it will stay in motion, unless it's acted upon by an external or unbalanced force. So this law, like I mentioned, is also called the law of inertia. So it'd be helpful to explain what inertia is. So inertia is the tendency or property to resist change in their state of motion. So that's why Newton's law is called Newton's first law is called the law of inertia, because here the point is that it's resisting change to their current state of motion. Okay, so if you are looking around you, right, as you're listening to this lecture, look at the things that are not moving around you. They're not moving and they are continuing to not move. If you look at something that, and we'll get into this when we get into his later laws, that if an object in motion is no longer staying in motion, so if it's slowing down, there's a reason that it's slowing down because there's an external force causing it to do so. So normally forces are balanced. Okay, so we know that if an object is at rest, or an object, is moving, right? We know that if it's at rest, it has 0 for velocity, right? And if it's moving, it doesn't equal 0. It has some sort of speed, right? Since we know that Newton's law states that if it's at rest, it will stay at rest. And if it's moving, it will stay moving. Right? Which means that in order to continue at this velocity, right, which is 0, the acceleration has to also be 0. So, and in order to keep moving, we have to have, no change in our acceleration here. So notice that the acceleration is 0 for both conditions. right? That an object is just going to keep doing what they're doing, right? Now, when a object no longer is at rest, or if there's a change, right? And what an object is currently doing, there was, I guess I should say there was a force being applied, okay? Or more, I guess I'd say more generally speaking, that the forces, right in the middle here, that the forces become unbalanced, okay? So if there's a change in what the object is doing, then now you know that the forces have become unbalanced. So, all Newton was trying to say is that things are going to continue. They have a natural tendency to continue to do the thing that they are doing. So, if they are at rest, they will stay at rest. And if they're in motion, they'll stay in motion. It is when these objects change. So, if an object was at rest, okay, so we have, here's me with a ball, right? And so if it's at rest, and if I go ahead and apply force to that ball, then the ball will move, right? So the tendency, right, for this ball to stay the same in the same position is an example of Newton's first law. You can think of um, a couple different examples here, right? So let's write down this one. You can think of when you are driving, let's just say you have a cup of coffee, right? And if you have a full cup of coffee, right, you just went to the coffee store or you brought it from your house, and as you get in the car, you turn it on, put your coffee in the cup holder. As you are accelerating, right, from resting, right, so your car was zero velocity and now you are changing your acceleration, which means you are now changing your velocity. The coffee, right, wants to continue to do what it was doing, which was staying at rest, right? So the road in this situation as you're driving provides this unbalanced force, right, on the wheels. And that's what's pushing this car forward. And so as the car goes, the coffee still wants to stay at rest. So while the car accelerates forward, the coffee remains in the same position, right? However, as the car accelerates, right, the coffee wants to be in the same position. The coffee accelerates, and unfortunately, the car accelerates out from under the coffee, right? And so, the unfortunately, if you've ever had this happen to you, where the coffee now spills out of the cup, right? So the same could be said for if you have a cup of coffee and you're braking, right? So either you're decelerating or accelerating, right? When you have this change in velocity, you are changing what it was originally happening. So what was originally happening in the initial scenario was that I was at rest and now I'm in motion. But if you are in motion and now at rest, the coffee is still going to come out of your cup. so I guess next time we're filling up coffee, we don't have to fill it up all the way, but we could also drink it before we start our car. So let's think of how a point I'd like to make here is how mass is tied into all this. And so this is kind of the final topic or the final point of Newton's first law. There's no equations to learn for Newton's first law. It's just the two principles here. So remember that inertia, right, is the tendency for an object to resist change, right, in its motion. And so we know that some objects have more inertia than others, right? Um, but we know this because the inertia of an object is measured by its mass. Okay, so these two words, mass versus weight, have kind of been used interchangeably, right? Um, so however, mass does not vary with location versus weight does. So what am I talking about here? I'm talking about that the mass of an object, right, is the same on Earth as it is in orbit or on the surface of the moon. It does not matter, right? The forces that are applied on the mass, you have an inherent mass. Your computer or phone has an inherent mass where you're hearing these lectures, right? If you're writing stuff down, everything has an inherent mass, right? The weight of an object, right, depends on the force, right? So it depends on the location and it depends on the forces that are applied, right? So the weight, I can actually get a more scientific definition here. So the weight is basically the force exerted on an object by gravity. And so that's why it varies with location, because it's based on gravity, right? So mass is just the amount of matter. In an object. So even though that we use these words interchangeably, it's very they have different different definitions. So you could um, now that you know this, you can, when we move on to Newton's third law, and we're doing free body diagrams, just remember that when we are using the word weight, that you need to incorporate gravity here. Okay, so just going over Newton's first law again. So he has three laws of motion. The first law is the law of inertia. Okay. His first law, right, is two parts. So an object will at rest will remain at rest, and an object in motion will stay in motion. Typically, this is in a straight uniform line, right, unless otherwise acted upon. So if you are like my son kicks a ball and then my dog tries to, intercept it, right? The ball will continue to roll straight in a uniform line until it's otherwise acted upon by friction or my dog. Inertia, right, has the definition, and it's the tendency to resist change in an object's state of motion. Okay. Okay. And then forces are traditionally balanced, right? So when the forces are balanced, right, I should say, then objects will remain how they are currently at. So when you have balanced forces, right, you will remain in your state. So when forces are balanced, there is no change in object's motion. Okay. And so if it's at rest, that means that your velocity is 0. If it's moving, it means your velocity is not at 0. In both situations, the acceleration has to be 0 because you can't be accelerating or decelerating without changing your velocity. Velocity, the difference in velocity is your acceleration. So if you can't change your velocity, then you have 0 acceleration, regardless if you're moving or not. And so if you're at rest, you'll stay at rest. And if you're moving, you'll stay moving when the forces are balanced, right? So when there's a change in what an object is currently doing, right? So now you're changing the motion, the state of motion, then you know that there is some sort of force being applied or taken away. And now you know that the forces are unbalanced, okay? And just a last example of just how mass is different than weight.